Dear students, today we will be learning the substitution method for evaluating the limits. Students, let us see where do we use this substitution method. Consider the limits of trigonometric functions in which x tends to a, where generally a takes the values such as pi, pi upon 2, pi upon 3, pi upon 4, pi upon 6, etc. In such a case, we put x minus a is equal to some t or h, or a minus x is equal to t or h, so that x tends to a, t tends to 0 or h tends to 0. So let us solve the sum and understand more clearly. Evaluate the following. Question number 1, first one. Limit x tends to pi upon 2 cosec x minus 1 upon pi upon 2 minus x the whole square. Here from the question only we will understand that what type of substitution we will take here. In the question, denominator is pi upon 2 minus x. Also the limit is taken as x tends to pi upon 2. So we will take the substitution pi upon 2 minus x instead of x minus pi upon 2. So pi upon 2 minus x is equal to h. And then x is equal to pi upon 2 minus h. Because we need the substitution for x in the numerator also. So both x term will be converted into h. So when x tends to pi upon 2, then h tends to what? Pi upon 2 minus pi upon 2, 0. Means x tends to 0 means x tends to pi upon 2 means h tends to 0. Now we will apply this substitution, that is limit x tends to pi upon 2 cosec x minus 1 upon pi upon 2 minus x the whole square will be limit h tends to 0 cosec pi upon 2 minus h minus 1 upon h square. Now cosec pi upon 2 minus h is what? Sec h. So limit h tends to 0 sec h minus 1 upon h square. Here sec h is equal to 1 upon cos h, and the limit h tends to 0 1 upon cos h minus 1 upon h square, which is equal to limit h tends to 0 1 minus cos h upon h square into cos h. That is, here we will cross multiply, then the denominator will be cos h. That will go to the denominator h square. Now limit h tends to 0, 2 into 1 minus cos h is 2 sin square h by 2. That is, in trigonometry we learned this 2 into sin square h by 2 by h square into 1 by cos h is taken separately. Now 2 is the constant, so taken out. So 2 into limit h tends to 0 sin h by 2, and here we made an adjustment that here h square is there in the denominator, so we divided this h square by 4 and make it h by 2 the whole square, and then we adjusted with that 4 by multiplying a 4 with this denominator, that is h by 2 the whole square or h by 4 into 4, like that. So h by 4 into 4. So this 1 by 4 is again to take out, this is also a constant again. So limit h tends to 0 sin h by 2 by h by 2 the whole square, because both numerator and denominator has the square here. Now 1 by 4 will go out, and then it is 2 by 4, that is 1 by 2. And we apply this limit for the 1 by function 1 by cos h separately. Now again limit h tends to 0 sin h by 2 by h by 2. We will take this limit inside the square also. Then we know limit h tends to 0 sin h by 2 by h by 2 is of the form sin theta by theta form. Because h tends to 0, then h by 2 also will tend to 0 only. So we can directly apply the limit by using the result limit theta tends to 0 sin theta by theta is equal to 1. So this part will be 1, and the limit h tends to 0 1 by cos h is cos 0. and we know cos 0 is 1. So 1 by 2 into 1 is equal to 1 by 2. Question number 1, third question. Limit x tends to pi root of 5 plus cos x minus 2 upon pi minus x the whole square. Here we will take the substitution pi minus x is equal to h. So x will become pi minus h. By taking this minus x to this RHS, then it will be x, and h to the LHS, then it is pi minus h. Now we know when x tends to pi, then h tends to 0, because pi minus pi is equal to 0. Then limit x tends to pi root of 5 plus cos x minus 2 upon pi minus x the whole square. That is, limit h tends to 0. X tends to pi will become h tends to 0. Root of 5 plus cos x is pi minus h minus 2 upon pi minus x again h the whole square. Now limit h tends to 0. Root of 5 minus cos h. Cos pi minus h is cos h only. Minus 2 upon h square. Cos pi minus h, that is in the second quadrant, it is second quadrant. Cos pi minus h is minus cos h. So plus cos pi minus h will become minus cos h minus 2 upon h square. Now we will this is like the limit containing the square root. So we will multiply both the numerator and denominator by this conjugate. That is root of 5 minus cos h plus 2. That is limit h tends to 0. Root of 5 minus cos h minus 2 upon h square into root of 5 minus cos h plus 2 divided by root of 5 minus cos h plus 2. That is limit h tends to 0. 5 minus this numerator will become, it is of the form a minus b into a plus b. So it is a square minus b square. So a square means the term containing the square root will get cancelled, and only the inner part, that is 5 minus cos h remains. Minus 2 square, that is 4, and denominator will be as it is h square into root of 5 minus cos h plus 2. That is limit h tends to 0, 1 minus cos h by simplifying the numerator. 1 minus cos h upon h square into root of 5 minus cos h plus 2. Limit h tends to 0, 1 minus cos h into divided by h square. Here the denominator 1 minus cos h. So we will multiply. That is just substitute and see whether you are getting the numerator and denominator 0. Here when you take h is equal to 0, that is by direct substitution method we have to check whether the numerator or denominator is becoming 0. Here the denominator, when you put h is equal to 0, then the denominator will become 0, and 1 minus cos h. Cos h is 1. Cos 0 is 1. 1 minus 1, 0. That is both numerator and denominator are becoming 0. So what we will do is we will again multiply by the conjugate of 1 minus cos h. That is 1 minus cos h, the conjugate is 1 plus cos h upon 1 plus cos h. Then 1 minus cos h into 1 plus cos h will be 1 minus cos square h. That will become sin square h, and then we can apply the trigonometric result, that is limit theta tends to 0, sin theta by theta form it is now. So limit h tends to 0, sin square h upon h square into the brackets containing the functions which will not be 0 when putting h is equal to 0. That is root of 5 minus cos h plus 2 into 1 plus cos h. Now we will apply the limit separately. That is for the function sin h by h the whole square we will apply the limit, and the remaining function also we will apply the limit. That is limit h tends to 0, sin h by h the whole square will become 1 square by taking this limit inside this bracket. Then the next one, that is limit h tends to 0, 1 upon root of 5 minus cos 0. that is by direct substitution of the limit, that is h is equal to 0, that is cos 0 is equal to 1. So root of 5 minus 1 plus 2 into the second bracket also containing cos h. So here also we can directly put h is equal to 0. So 1 plus cos 0, that is 1 plus 1. Now 1 into 1 by root of 5 minus 1 is 4 and root 4 is 2. So this will become 1 upon root of 4 plus 2 into 2, and root of 4 is 2 plus 2, 4, 4 into 2, 8, that is 1 upon 8 is the value of the limit. And the remaining sums in this exercise are continued in the next video. Thank you.